Okay, suppose we have two people, A and B, they're both walking this way. So the velocity of the person A is labeled as AG. Now why G? So G means the ground. Okay, and then the person of B has a velocity VBG. Now you can tell all the velocity you must have a relative to something, right? We don't really say the velocity of person A is the velocity relative to the ground, because that we take as granted. But it is relative to the ground. If you're supposed to, if the ground is a piece of maybe a board, it is moving itself, and then your velocity is different, right? So, okay, let's say, just give a number. So the person is, A is 2.0 meter per second. So moving to the right relative to the ground. This person is 1.0 slower. Okay, now let's try to find out the relative velocity. Velocity of A relative to B. So we would write velocity AB. Right? Make sense? Velocity A relative to B. Okay? So now it would be pretty easy to figure out because the person is faster, the A faster, and the B is slower. So if they walk at the same position and walking towards the same direction, the A is going to be faster and ahead of the B, right? So you can see the velocity relative, velocity A to B is simply VAG minus VBG. And the result is pretty straightforward, 1.0 meter per second. Right? So no question about it. Let's try to make it a little bit complicated by, let me copy this. Okay, so I'm going to change a little bit. So the VB is going to be reversed. Okay, since it's reversed, when we have two objects moving towards opposite direction, and if we say the VAG is 2.0, do you have to change something to the VBG? You have to change negative, okay. So otherwise you can't describe the situation, accurately. Right? Now we can tell difference. Okay, VBG is negative, means the other direction. Now if we still want to find out the VAB, do we do VAG minus VBG again? Do we have to modify this formula? Do we need to? Now first of all, come up with an idea. When it's opposite, so what is the relative velocity of A to B? How much? It's still 1, so you think it's still exactly the same situation. Then should it equal 3.0 meter per second. Okay, the direction is still the same direction towards the right. Okay, now we can add right, or you can see east, right? Okay, now actually you can see, even though the situation is different, and the formula is exactly the same, right? In this case, If you want to do the calculation, it's actually 2.0 minus negative 1.0, right? It is equal 3.0. Right? So that's why. Okay, now this is actually the definition. So relative velocity of A relative to B. Now as long as A and B, they both have the velocity relative to a third object, which is the ground, and this formula is always true. Always true. Okay, now don't forget, this formula is supposed to be dealing with vectors. Okay? Now why I didn't put the vector sign? Because when you deal with one-dimensional object, it doesn't really matter. As long as you figure out which is positive, which is negative, it doesn't really matter. Okay? So now let's try two-dimensional. Okay, two-dimensional. Okay, so if I have a car moving this way, and another car moving the other way. So this one is car A, this one is car B. So the velocity of the car A is V A ground. The velocity of car B is V B ground. Okay? So that's a given number.
Please excuse the interruption. At this time, if I could please ask teachers of grade.
Okay, the car A is 10 meters per second. The car B is 12 meters per second. So find velocity of car A relative to B, car B. Okay? Now this is exactly same formula should be applied. We just write V A B. So that's the vector velocity that we need to find out. Okay, and it's always equals VA G again. Okay, it's the same thing. G again is the ground. Subtract V BG. Okay, straightforward. Now some people might like to do some, you probably think, oh, I don't like addition, subtraction. So can I do addition? No problem. Move this one to the other side. So then you get, now of course we need to find out this, right? So the relation, you can manipulate the relation is actually V A B. So I move this negative over to the left side. So plus V BG equals V AG. Right? If you're comfortable with addition, no problem. But this question is really asking to find out this, right? So this is actually something we need to find out. And then you need to do the subtraction between the two vectors. Okay? Now basically, the physics part is done, right? So you already figure out you need to subtract the vector VBG, which is here, 12 meter east, right? From another vector VAG, which is 10 meter per second north. Done. we already learned how to do the subtraction between two vectors, and then you can see it's always easy if you know the vector addition, subtraction. Okay, so now we need to construct a triangle to do this, right? Okay, we do subtraction a couple of different ways. So now the easy way, let's do the fast way is, okay, so this is A, this is B, a little bit longer supposed to be. Okay, now if you write, put them in this position, tail to tail, see they all start from this point. And then the subtraction is supposed to be, so this would be A, G, V, B, G. The subtraction between depends on it's A, B or B, A, right? So it's A minus G, so you need to draw a line from the B towards the A. So this is the difference between VAG and VBG. And it's VAG minus VBG. So this is VAB. And this is a very easy question because we know this angle is right angle. So this is 10, this is 12, right? And just find out this. So the VAB is actually equals 10 squared plus 12 squared, right? So the calculation part, it's easy to do. You can do that later. And then there's the angle, right? So this is angle theta. So the theta is supposed to be tangent -1, 10 over 12. Okay, that's also easy, right? So now if on the test, if you draw the angle theta labeled like this, you don't need to tell me it's like north of west, right? You just tell me how much the VAB is, how much the theta is. That's enough. I can clearly tell, right? But of course, you need to understand to tell people the direction. You should see it's north of west. Okay, not north of east. Okay, so now you can take answer is 15.6 meter per second for this the velocity, and then 39.8 degree north or west, right? So if you need to write a statement, it's 15.6 meter per second and 39.8 degree north of west. Okay, now very important is you can make sense if we go back to the one-dimensional. So you can make sense the velocity of A relative to B is still go to the right. This this situation, even though the B is going backwards, and the A velocity relative to B is still going to the right. Okay, easier to make sense. But how about this situation here? So the question asking for the velocity of A relative to B. Okay, now think about this way. To make sense, initially suppose they start from exactly the same point, and then after 1 second, so the A is going to arrive 10 meter north of this initial point at here. After 1 second for the B is 12 meter right to that initial point. Okay, if you count the distance between them, that's exactly supposed to be 15.6 meter. And then if you count the not just distance, displacement, it has the angle. The angle is exactly this angle. So that's why, so the velocity between the A and the B is how much distance traveled relative to you and plus the direction. Okay, that's exactly should have a velocity pointing to this direction, right, and relative to you. So that's the VAB. It should be 15.6 meter per second, and then this angle 39.8 north of west. Okay? Okay, what if the question asking for the velocity of B, the car B, relative to A, right? So the original question is asking for A relative to B, right here, A to B. Now it's B to A. Now can you write the answer right away? So what is the answer? V, B, A. How much is this? Do you have to go through all the calculation to tell? Can we borrow some number from this calculation? Yes, Jeffrey. So can you tell me what's the result? BA. B relative to A. Pardon me? 15.6. 15.6. What's the direction? South of east. That's exactly true. Okay, because if you want to draw the graph is really just becomes this. You can copy this graph right here. Then, of course, we need to change this. Okay. So that's the new direction for the velocity B relative to A. Okay, and the angle is a little bit tricky. You have to think it that way. If you extend the direction of the VBA and then extend a little bit to the east direction, so this is exactly the same angle, and then this is your direction of the VBA. Right? Of course, it's supposed to be south of east. Okay? Now you can see that's actually this question. The understanding is about you need to make sense of what is relative velocity, right? So it's really based on what's the displacement over time. So if we calculate the displacement, you can see that's the direction of the displacement, and also that much magnitude of that displacement, and over time, right? So you just count as 1 second, so you can easily figure out that's exactly true. Okay? So let's look at an example of a boat crossing a river. So you're going to see a lot of similar questions. So it's all about talking about a boat crossing a river. And very similar to an airplane, they're moving in windy air, right? So the air is moving just like the river, water is moving. So if you know how to do this, it will be transferable, your skill to this. Okay, let's look at a situation. So if you have a river, okay, so normally we say this is the shore, right? So that's the bank of the river. So then the water is moving. Right, so that's labeled as V W relative to the shore, or actually just the earth, right? Okay, so we need to label it here. So W means water, right? And then S means the shore. And then we have a boat. Okay, so boat is trying to cross the river. Okay, going this way. So this is a V, B to W. Now this is a very important concept. So the B, first of all, let's put this label down, means the boat. So the VBW of course means the velocity of boat relative to water. Okay, now if the boat has a maximum velocity of, let's give to 5 meters per second, and then this one means the velocity relative to the water only. Okay, it actually because the velocity of a boat is really depending on the engine and then the propeller against the water. So they don't really know is the water moving or not. You don't really know. For example, if you just put the boat, turn off the engine, just let the boat float on the surface of water. So the boat is going to move together with the water with exactly the same velocity. Now let's give it to 2.0 meter per second. Okay, so the boat is going to simply move. And when the water stops, the boat is going to stop as well. So the boat really doesn't know if the water is flowing or not, right? The boat doesn't know. So this velocity we can call the velocity of a boat relative to the water, or we can just still, okay, velocity. Okay, sorry, it should be velocity in still water, because there's no difference. Doesn't matter if the water is moving or remains still, so the velocity is always the same. Okay, I'll show you a demo later. Okay, so yeah, if we know the boat is supposed trying to move north 5 meters per second crossing the river, but the water is moving, right? So and then we need to find what's the real velocity of the boat V B relative to the shore. Okay, so that's the thing we need to find it out. Now, according to the formula we have for this one, so V B S VBW. Okay, VBW is the velocity boat relative to water. It's supposed to be VBS subtract V water S. Okay, now if you check all the information, what you know, so we actually already know the subtraction, the difference. Okay, so the relative velocity B relative to B, we already know that. That's 5 meters per second. We also know the VW to WS, that's water's velocity relative to the shore. Now we actually trying to find out this. Okay, and it's pretty easy. If you want to find out this, just isolate this, right? Move this one to the other side. So the VBS is actually equals VBW plus VWS. Okay, now when you form this kind of additions equation, so you can see this pattern. So in between of these two vectors added together, so you have the exact same number in between them. And then this number, the B, exactly, you can find the B over here, and then this S is here. Okay, now this is some people like to memorize the formula this way. Now again, this formula is equivalent to this, right? And if you can make sense of this, you can always start with this formula and then transform to this, help you to do the math. But if you want to always start with this, not a problem, and you can memorize this pattern. Okay, as long as you label them correctly, and you should have an addition equation for all similar questions. Okay. Okay. Now the physics part is done again. Now, depending on this equation, you need to add this vector we both know, right? The both we already know. BW equals 5, direction north. VWS 2.0, direction east. We can easily construct a triangle to do this, right? Okay, so this is VBW, and if you want to do addition, it's depending what you like. If you want to do the tip to tail, fine. If you want to do tail to tail first, so you have to draw this shorter, okay? See, if you want to do this one, so this is a 5 meter per second, right? So this one is 2 meter per second. Now if you put them tail to tail, and then you don't do this, if you draw a line here, that's subtraction, right? So if you do addition, you construct a parallelogram, but in this case it's not really parallelogram because this is a right angle, so it's a rectangle, right? Okay, so then the sum is really just the diagonal, right? So the diagonal starting from this point. Now if you draw this way, it is also a diagonal, but that's not the addition, right? If you want to do addition, this is. So this should be the V boat relative to the shore. Okay, again, look at one of the triangle. This is a 5, this is 2. So this one would be simply two squared plus 5 squared equals, and this is the angle we need to find it out. Theta equals tangent -1 5 over 2, right? We can calculate that later. Okay, we calculated this 5.4 meter per second and 68 degrees, so the direction should be north of east. Okay, now we don't just follow this formula to do the calculation. In physics, the most important thing is you need to make sense. But this is the easier case. If you have water moving, and then you try to go cross the river directly to the north, and because the water is going to carry you down the stream, so you end up moving that way, right? So that's really you may end up at this kind of approximately this point, right? So that's your actually destination. And sometimes if you do want to cross the river directly, okay, you have to go this way, right? Let's explain the situation. So this is another type of question. I can let you think about it. Okay, so if you want to cross the river, so if that's your boat, your boat is here. If you want to cross directly to the river, and you already know the water is moving, right? You already know the water is moving this way. So the same situation, let's put a exact same number. So the V water to the shore is 2.0 meter per second. And then if you do want to go this way, directly to the north, okay, if that's the path you want to take, and then you have to go this way actually, depending on how much the speed of the water, right? Okay, if you go this way, and the boat should look like this. Okay, and if you go this way, so this is your V boat relative to water. So if this still equals 5 meter per second, and then eventually you can go that way. Now if we draw the same vector diagram, so we should move this one over here. So you can see we still put them in tail to tail, just like here. So this is the V, B, W, S. And then this time we really have to construct a parallelogram. It's not a rectangle anymore, right? Because the angle between these two vectors is now 90 degrees. And then you can see that's exactly your resultant. So then you end up going this way. And then the angle here, the angle theta. Now if you look at this triangle, this one's supposed to be 2. Right, and then this is 5, this is 5, and this is actually something we don't know. So this is a V, B, S, right? So now it becomes, we know we need to find out this, right? So this is the question is just different situation. If the boat wants to cross the river directly north of starting point. Okay, now that's the goal, right? So the board wants to go directly north. And then we still have the 5 and for the boat and 2 for this. So the question is asking for find the angle theta. So basically the question is asking for, okay, what kind of angle I should aim, you know, according to the graph, so that I can achieve this goal. Okay, that would be a very typical question, right? So I leave the question here, you know, and give you a couple of minutes to think about it. Okay, the answer is 66.4 degree, and should be north of west. Okay, it's not same angle as the earlier question, because you can see the different triangle, right?